Exploratory Data Analysis or EDA is the foundation of a data science project. Before building models, EDA helps you understand your data's structure, quality, and patterns, revealing underlying data quality issues, feature relationships, distribution insights, and business context that guide smarter decisions throughout the entire workflow. By systematically exploring data quality, engineering meaningful features, and visualizing relationships across variable types, you can uncover hidden patterns and catch potential issues early, saving hours of debugging downstream and ensuring that any models you select and build are grounded in a solid understanding of the data. Firstly, know the basic statistics of the dataset by importing the core Python libraries for data manipulation and visualization, to get a high-level understanding of any dataset using functions like info and describe, to inspect data types, basic statistics, and overall structure. We then focus on detecting and quantifying missing values, turning raw counts into percentages and visualizing them to reveal which fields may need attention before deeper analysis. Building on these insights, we introduce feature engineering as a practical way to transform raw fields into more informative variables, for example turning complex fields into binary flags or extracting date fields into year and month. Apply data transformations to convert complex fields into cleaner numeric or categorical features, and decide whether to keep or drop for further analysis. The next step is categorize these variables into numeric and categorical groups so that each can be analyzed with appropriate techniques, setting up a reusable pipeline that leads naturally into the process of univariate and multivariate analysis. Univariate analysis examines and summarizes one variable at a time, focusing on its distribution, central tendency, and variability. To perform univariate analysis systematically across the entire dataset, we can use bar charts for categorical features and histograms for numerical features to inspect distributions on datasets. Then perform multivariate analysis to examine two or more features at the same time to find patterns, correlations, and relationships among them. For relationships between pairs of numerical variables, apply correlation matrices, visualized as heat maps, with Seaborn pair plots to reveal both linear and nonlinear patterns. For categorical relationships, build grouped bar charts using Seaborn count plot with hue, iterating over pairs of categorical variables. This reveals whether any feature contributes to significant differences in data distribution across groups. For categorical numerical relationships, box plots are useful to compare numeric distributions across categories and flag differences worth deeper statistical analysis. We can further enhance the EDA process of two numerical and one categorical features by using pair plots with categorical variables as hue, making it easier to visualize any potential clusters formed in the numeric feature space. Let's recap. The EDA workflow begins with understanding the dataset's basic statistics, then moves to data manipulation and feature engineering, cleaning, transforming, and crafting informative features from the original data. Then perform univariate and multivariate analysis to uncover patterns and relationships. If you enjoyed this video, comment below with other data science topics you'd like to explore, and check out the full blog post linked in the description.